In this video, we're going to analyze hyperbolas with center at a point h, k. Now, if we start with a hyperbola that has a center at the origin and transverse axis that is a coordinate axis, and we shift horizontally h units and then vertically k units, the result is a hyperbola with center h, k and transverse axis parallel to a coordinate axis. The equations of such hyperbola have the same form as those whose center is at the origin, except that x is replaced with x minus h and y is replaced with y minus k, representing the horizontal and vertical shifts respectively. The best way to learn how to analyze a shifted hyperbola is to think of shifting the hyperbola whose center is the origin and remember the distances and asymptotes described in the original form. Now, to emphasize the connections, on the next two slides, we present the corresponding information of a hyperbola with center at the origin and its shifted counterpart. On the left-hand side of this slide, we have the graph of the hyperbola, x squared divided by a squared minus y squared divided by b squared equals 1, where b squared equals c squared minus a squared. And the center is at the origin. The transverse axis is the x-axis. And keep in mind that since the y squared term is subtracted in the general equation, and thus the x squared term is being added, this indicates the transverse axis is horizontal and coincides with the x-axis. Furthermore, the foci are a distance of c from the center along the transverse axis, thus located at the points plus or minus c, 0. Vertices are a distance of a from the center along the transverse axis, thus located at the points plus or minus a, 0. And the two asymptotes are y equals b over a times x and y equals negative b over a times x. These are lines with slopes b over a and negative b over a. On the right-hand side of the slide, we have the graph of the hyperbola, square of the quantity x minus h, all divided by a squared, minus square of the quantity y minus k, all divided by b squared, equals 1, again where b squared equals c squared minus a squared. In this form, the center is h, k, the transverse axis is parallel to the x-axis, foci are a distance of c units from the center along the transverse axis. Now, since the axis is horizontal, then we move c units horizontally from the center, so the foci are located at the points h plus or minus c, k. Vertices are a distance of a units from the center along the transverse axis. Moving a horizontal distance, a, from the center, the vertices are located at h plus or minus a, k. And finally, the asymptotes are y minus k equals plus or minus b over a times the quantity x minus h. Again, these are two lines, one with slope b over a and one with slope negative b over a. Now, on the next slide, on the left-hand side, we have the graph of the hyperbola y squared divided by a squared minus x squared divided by b squared equals 1, where b squared equals c squared minus a squared. The center is at the origin. The transverse axis is the y-axis. Again, we can identify this from the equation. Since the x squared term is subtracted, and thus the y squared term is being added, this indicates the transverse axis is vertical and coincides with the y-axis. The foci are a distance of c from the center along the transverse axis, thus they're located at the points 0, plus or minus c. Vertices are a distance of a from the center along the transverse axis, thus they are located at the points 0, plus or minus a. The asymptotes are y equals a over b times x and y equals negative a over b times x. Again, two lines whose slopes are negative a over b and a over b. On the right-hand side, we have the graph of the hyperbola, square of the quantity y minus k, all divided by a squared, minus square of the quantity x minus h, all divided by b squared equals 1, again where b squared equals c squared minus a squared. The center is h, k. The transverse axis is parallel to the y-axis. Foci are a distance of c from the center along the transverse axis. Again, since the axis is vertical, then we move c units vertically from the center, thus the foci are located at the points h, k plus or minus c. Similarly, vertices are a distance of a units from the center along the transverse axis, which is vertical, thus they are located at the points h, k plus or minus a. And then the asymptotes are y minus k equals plus or minus a over b times the quantity x minus h. Again, we don't really want to memorize all this information for the shifted version. It's best to use our knowledge of the hyperbola at the origin, the corresponding distance relationships for the vertices and the foci, and then shift all the information accordingly. In this example, we're told to find an equation for the hyperbola with center at -1, 2, one focus at -4, 2, and one vertex at 1, 2. Then graph the equation. First, let's plot the given information on an xy grid using an xy coordinate plane from -6 to 6 on both the x and y axes. Let's plot the center at the point -1, 2, one focus at the point -4, 2, and one vertex at the point 1, 2. Now, since the given focus is to the left of the center, we denote it as f sub 1, and the given vertex is to the right of the center, so we'll denote that as v sub 2. Now, because the given center, focus, and vertex lie on the horizontal line y equals 2, then the transverse axis is horizontal and is parallel to the x-axis. Therefore, the equation has the form square of the quantity x minus h all divided by a squared minus square of the quantity y minus k all divided by b squared equals 1. So we need to find the values of a squared and b squared. To begin, we know the vertices are a distance of a from the center along the transverse axis. Since the center is at the point -1, 2, and the given vertex is at the point 1, 2, then a is the horizontal distance between these 2 points, which is a equals 1 minus -1 or 2, thus a squared will equal 4. Now to find b squared, we know for a hyperbola that b squared is equal to c squared minus a squared. And we need to find c squared in order to find b squared. So to find c, we know that c is the distance from the center to the foci. Since the center is at the point -1, 2, and the given focus is at the point -4, 2, then c is the horizontal distance between these 2 points, which is c equals -1 minus -4, or 3, thus c squared equals 9. So to complete our calculation of b squared, which is c squared minus a squared, we have 9 minus 4, which equals 5. So now that we know the values of a squared and b squared, and the center h, k being -1, 2, then we can write the equation of the hyperbola as square of the quantity x plus 1 all divided by 4 minus square of the quantity y minus 2 divided by 5 equals 1. So we have solved the first part of the problem, which was to find the equation of the hyperbola. So to finish the problem, we need to graph the hyperbola. We were told one focus is at the point -4, 2, and we determined the distance from the center to this focus was c equals 3. Now, since this focus is to the left of the center, then we know that the second focus will be 3 units to the right of the center at the point 2, 2, which we'll go ahead and denote as f sub 2. And next, we're told one vertex is at the point 1, 2. We calculated the distance from the center to this point to be a equals 2. And since the given vertex is to the right of the center, then the other vertex will be 2 units to the left of the center at the point -3, 2, which we will denote as v sub 1. Now we want to sketch the box or the rectangle that will aid us in drawing the asymptotes. Now recall that the rectangle will contain the 2 vertices as well as the 2 points that are a distance of b from the center along the conjugate axis, which in this case is a vertical distance from the center. So we will plot the points h, k plus or minus b. And since b squared equals 5, then b equals square root of 5, which is approximately 2.24. So these points lie at -1, 2 plus or minus square root 5, which is approximately -1, 4.24 and -1, -0.24. Now let's plot these 2 points in our coordinate grid. Now, with the two vertices and the 2 points we just plotted, we can draw our dashed rectangle that will help aid us in drawing the asymptotes. And once this rectangle is complete, we can extend the diagonals of the rectangle to obtain the asymptotes. So lastly, let's draw the two branches of the hyperbola that will open to the left and to the right, each branch containing its respective vertex and approaching the asymptotes. In this example, we're told to analyze the equation of the hyperbola y squared minus 4x squared minus 2y minus 8x minus 7 equals 0. Now, the first thing we need to do is put the equation in the general form by completing the squares in x and in y. And we begin by completing the square by grouping the x variables together and the y variables. Also, we need the squared variable to have a coefficient of positive 1. Therefore, we begin by writing the equation as y squared minus 2y minus 4 times the quantity x squared plus 2x equals 7. Now, a few comments here. We put parentheses around the two terms y squared minus 2y, and we leave a little extra space inside the parentheses so we can add the necessary constant that completes the square on the y terms. We did the same thing with the two x terms, but we also factored out a negative 4 from the two x terms so that x squared has a coefficient of positive 1 inside the parenthesis. And then the last note is we added 7 to both sides of the equation, so we only had variable terms on the left-hand side and a constant on the right-hand side. Now to complete the square on the y and x variables, keep in mind the process is that now that the squared variable has a coefficient of positive 1, we then take half of the coefficient of the linear variable and square it and add that number inside the parentheses. Now we need to add to both sides of the equation to keep the equality true. So inside the parentheses of the y terms, we take half of negative 2, which is negative 1, square that and get positive 1, and then we add 1 inside the parentheses containing the y terms and then add 1 to the other side of the equation to keep the equality balanced. Now for the x variables. The linear variable has a coefficient of 2. We take half of 2, which is 1, square that value to get 1. So we're going to add 1 inside the parentheses containing the x terms. Now let's note that we had factored negative 4 out of the x terms. So technically we have 1 inside the parenthesis, but negative 4 times that. So we've added negative 4 on the left-hand side of the equation, which means we need to add negative 4 on the right-hand side of the equation. Now, since we've completed the square on both the x and y variables, let's factor the perfect square trinomials inside each set of parentheses and write the equation as square of the quantity y minus 1 minus 4 times square of the quantity x plus 1 equals 4. So our last step is we need the right-hand side of the equation to be 1. So we divide both sides of the equation by 4, and we write square of the quantity y minus 1, all divided by 4, minus square of the quantity x plus 1 equals 1. So now the equation matches the form square of the quantity y minus k, all divided by a squared, minus square of the quantity x minus h, all divided by b squared equals 1. So we can now identify the center of the parabola to be h comma k, which is negative 1 comma 1, and a squared is 4, and b squared is 1. So now that we have the equation in the proper form, let's go to a new page so we have some more room to write. Now, carrying over the equation and the information about the center and values of a squared and b squared, let's note that since the x squared term is being subtracted and thus the y squared term is being added, that the transverse axis is parallel to the y-axis. Now, since we know a squared and b squared, let's calculate c squared. For a hyperbola, we know that c squared is equal to a squared plus b squared, which equals 4 plus 1, or 5. So let's start plotting information in an xy grid. Here we have an xy grid from -4 to 2 on the x-axis and -4 to 5 on the y-axis. As noted earlier, we can plot the center at the point -1, 1. Now let's go ahead and determine the vertices. The vertices are a distance of a units from the center along the transverse axis. Now, since a² equals 4, then a equals 2. Now, the transverse axis is parallel to the y-axis, then the vertices are a vertical distance of a from the center and lie at the points h, k plus or minus a, which is -1, 1 plus or minus 2. So these are the 2 points of the vertices that have coordinates -1, -1 and -1, 3. So let's plot these 2 points on our coordinate grid. At -1, -1, we have v sub 1, and at -1, 3, we have v sub 2. Now let's find the foci. We know they are a vertical distance of c from the center along the transverse axis. And since c² equals 5, then the foci are √5 units from the center. Therefore, the foci are located at the points h, k plus or minus c, which is -1, 1 plus or minus √5. I'm getting out a calculator to just approximate the y values. The 2 points we would have are approximately -1, -1.24 and -1, 3.24. So let's plot f sub 1 below the center and then f sub 2 above the center. Now the last steps for graphing involve drawing the rectangle that will help us sketch the asymptotes. For the box that aids us in drawing the asymptotes, recall that the box will contain the 2 vertices as well as 2 points, a distance of b from the center along the conjugate axis, which will be a horizontal distance in this case. So these points will lie to the left and right of the center, and they will have coordinates h plus or minus b, k. Since b² equals 1, then b equals 1, and the points are -1 plus or minus 1, 1, which are the 2 separate points, -2, 1, and 0, 1. Now let's plot these 2 points and our coordinate grid at -2, 1 and 0, 1. And now we draw our dashed rectangle containing the 2 points we just plotted and the 2 vertices. And once our rectangle is complete, we can extend the diagonals of the rectangle to obtain the asymptotes. Oh, now we draw the lower branch of the hyperbola that opens down, containing the vertex v sub 1 and approaching the asymptotes. Then we draw the upper branch of the hyperbola that opens up, containing v sub 2 and approaching each of the asymptotes. Finally, let's provide the equations of the 2 asymptotes. Now, considering the asymptote whose line has a positive slope, think of the center of the hyperbola at -1, 1 as 1 point on that line. And to get to a second point on the line, we have to move to the upper right corner of our rectangle. So to do this, we have to rise a distance of a and run a distance of b. So the slope of this line is a divided by b, and thus the slope of the other line would be -a divided by b. Now, since the lines are shifted horizontally, h equals -1 units, and vertically k equals 1 units, then the 2 asymptotes have equations of the form y minus k equals plus or minus a over b times the quantity x minus h. So this gives us the 2 equations. Y minus 1 equals -2 times the quantity x plus 1, and y minus 1 equals 2 times the quantity x plus 1. Well, therefore, we've completed the analysis of the equation of the hyperbola and provided its graph.